All right, I am going to work through these problems, and you can pause at any time, but I would like you to try each problem ahead of time, so, and then, kind of follow my example if you need to. Number one, which was 10x 5x squared minus 3 to the 6th dx. This one I think you could probably do just on inspection, but I always default to u substitution. So the first thing I'm going to do, I see that this part is 1 degree higher than this part. So I'm going to make what's in the parentheses my u. U equals 5x squared minus 3. I'm going to take the derivative of that with respect to x, and that gives me 10x. And then I'm going to isolate the du part, pretty much always. And now I see that the 10x dx matches this exactly, the 10x dx. And I can rewrite the integral in terms of u and only u. So that integral is equivalent to the integral of u to the 6th, right? Here's my u to the 6th, du, because du, the 10x dx, is right there. And now that is much easier to integrate. The integral of that is u to the 7th over 7 plus c. And now I back substitute. I replace the u again with what the u is, all this stuff. So I've got 5x squared minus 3 to the 7th over 7 plus c. And then what I would want you to consider, at least for a while, is to be able to check your answer to see if it's right. If I now take the derivative of this, I should get this. And if I don't, then something's wrong. So to take the derivative of that, I would think about it and just rewrite first. 1/7 5x squared minus 3 to the 7th plus c. And I'm taking the derivative of all that. I just wanted to bring the 1/7 outside, or I could even written it out there, right? I don't have to take the derivative of 1/7 at all. It's a scalar multiple. So I've got 1/7, and now if I'm taking the derivative of that part, my first thing is to multiply by 7, so times 7 over 1, and then what's inside the parentheses is chain rule. Remains unchanged. The exponent goes down by 1, multiplied by the derivative of what's on the inside, or the derivative of that. And I'm writing it in red, which is 10x. And then clean this thing up. The derivative of c, of course, is 0. Clean this up as 7s are going to cancel, and I'm left with 10x, all this, which, with my circles all over, that's 5x squared minus 3 to the 6th. If I look in the purple part, 5x squared minus 3 to the 6th times 10x times 10x. So I know that my answer, which is right here, is correct.